So hello, and I really appreciate the opportunity to come speak to you this evening. Um, Again, my name is Jeremy Clark, and I'm in the Western US, so about 8 hours away time zone wise. And I want to talk about channels because this is something that I didn't know about until a short time ago as well. And I do a lot of kind of concurrent code and kind of showing people how to use task and await and other things like that. And then parallel code interests me quite a bit as well. And I found that channels can kind of make a pipeline easier in a lot of circumstances. So if you want to find me online, I'm Jeremy Bytes. So I have a website, jeremybytes.com. And I'm also on Twitter at Jeremy Bytes, as well as YouTube and kind of everywhere else. So that's where you'll be able to find me. If you want to find these slides, you can go to my website, jeremybytes.com, and get those. There's a link there to a GitHub repo that has the resources for this evening, which includes the slides, the code samples, and a bunch of links to articles and other things as well. And I believe I have a helper that will paste those links into the Twitch chat as well. So you should see those. In fact, I see them kind of going by right now. So with that, let's go ahead and get started. So there's kind of two main sections we're going to talk about. First is a producer-consumer problem. And this is something that channels can really help us solve. And so that's the problem space we're going to be looking at. And then after that, we're going to look at channel of T. And there's not a whole lot to it as far as operations. So we'll look at how to create a channel, how to write to a channel, how to close a channel once we're done writing to it, and how to read from a channel. So, and I learned in code, so don't expect a lot of slides. So hopefully that's okay with everyone online. So a little bit about channel of T. This was something that was rolled into kind of the standard stuff in .NET with .NET Core 3.0. And I just found out yesterday that it existed before that as a separate NuGet package that you could install. So I'm learning new stuff about this as well. And the way that I came across this is that I was exploring the Go language, and it has this concept of a channel, which is a way to communicate between concurrent operations. So in Go, there's a Go routine, which is an asynchronous method. And a channel makes it really easy to communicate between them so that you can set up, one asynchronous operation is producing data, another one's consuming data or grabbing the results and doing something with it. And so I started blogging about that, and somebody said, hey, do you know, what do you think about channel in C#? And I'm like, what do you mean channel in C#? And that's when I started looking at it and doing my experiments, and I've got a lot of concurrent code, so I'm going to show some of that tonight. Now, kind of functionally, it's similar to a concurrent queue. So a thread safe queue, so you put data in one end and and you can read it off of the other end. But some of the differences between a channel and a concurrent queue is that a channel has a separate reader and writer property so that we can make it really clear what we're doing with this object, whether we're putting things in or taking things out. And another big thing has to do with signaling. So being able to say, hey, I'm done writing to this channel, so you're not going to see anything else in it. And to me, those are some things that make it, again, really compelling in this space. Now, one thing this is not for communicating between distributed applications. So for those of you who are looking for alternatives to whatever type of service bus you're using right now, channels isn't that. So this is really useful for, I'm going to stay away from the word process because process is such a loaded term in our industry. But I'll say within a single executable. So we can have concurrent operations that can communicate with each other. So let's think about a little bit about the problem space. So a lot of times we need to get data and then use data. And this is a common scenario. And then sometimes we want to do this faster. And so I'm thinking about kind of the task with a continuation in the C# world where it's like, okay, I have a task, it goes out, it gets some data, produces some data, and then maybe I have a continuation that says, okay, once that task is done, go ahead and do something else with it. But then, okay, I need to do this faster. So what do? Well, I make more of these and just kind of run them all concurrently. So now I have these parallel operations that are all producing data and doing something with that data. And this situation works fine. You know, I've used it. There are some times you have to work around things. Sometimes when you're using the data, the operations you have in place aren't necessarily thread aware or thread safe. And so you have to do some interesting things to compensate for that. But this model kind of works. Well, I found that the producer consumer model is something that, again, is really good for the types of things I typically do. So we can think about it this way. I have some producers. In this case, too far. In this case, we have two producers that are just kind of going and grabbing this data or producing this data or whatever. And then once they get it, they dump it into a funnel. And then we can basically read out of the other end of that funnel to set up this pipeline. And so this is the scenario that I find channels really useful, because we have our producers that are doing their own thing. We have our consumer that's doing its own thing. And then the channel in the middle that's facilitating the communication. Now, the example that I have here has a single consumer. So we're reading things one at a time out of the channel. And that's actually the examples I'm going to show in code as well. But with channels, you can have multiple readers. So if I wanted to have multiple consumers that were running in parallel, perfectly able to do that with channels as well. So kind of interesting how all of this stuff fits together. So again, really, if we have producers and consumers, they can communicate asynchronously through a channel. So that's what channels are really, really good at. So with that, let's take a look at the major operations. So the channel of T, again, we'll need to create a channel. Then we'll need to write to the channel. We'll want to close the channel when we're done with it. And we'll want to read data off of this channel. And I'm tired of slides. So I'm going to go off of slides and go into code. And hopefully that makes everybody happy. It makes me particularly happy. And there are more slides. And if you go out to the GitHub repo, you can get those slides. And we'll take a look at them at the end to see if I actually covered the things that I promised to. So in this solution that I have, this is our channel demo solution that you'll find in the code samples. I have two projects. One, people.service is a web service, and that's providing the data that we'll use. The people viewer is a console application, and we have a person reader object in here that we will use. So I will collapse to definitions here. We're not going to worry about the details of this, but this has the methods that we're going to call within our code. So on line 20, I have a class which is a person reader that has some static methods in it. Line 25 has a get IDs async. So we have a set of data, and I want to get the IDs that are in our data collection, basically. So that's going to return me a list of integer wrapped in a task, because tasks are fun. And so that'll give me a list of the IDs that I have available to me. The other method that we have on line 38 is get person async. So we pass in an ID, and then this again will make a service call and return us one of these person objects. And the person itself, it's on line 9 at the top of this particular file. And it's a record, and it's basically the shape of our data. So there's an ID, a given name, a family name, a start date, a rating, and a format string, and then an override of the toString method. So this is what we're going to be consuming at this point. So I'm going to flip over to the console application that we'll be looking at. And what I've done here is I've set up multiple scenarios so that we can kind of explore how channels are beneficial to us. So in this particular one, on line 15, we call that get IDs async so that I can get the collection of IDs that we can use. And then these will be passed to separate methods where we perform our actual work. Line 20 is our first one that we'll be looking at, which is doing this synchronously, so no concurrent code. And then we have other examples that we'll be looking at. And then the rest of the code, kind of the stuff at the top and the stuff at the bottom of this main method, has some timing code so that we can see how long this particular thing takes. So let's start by looking at option 1, where we're running things synchronously here. And that starts on line 35. So this is no concurrent code at all. So we're going to just for each over the IDs. So for each ID in the collection. And then on line 39, we call the getPersonAsync method with that particular ID. And in this case, we're awaiting it. So this is going to wait for that asynchronous task to complete before it continues. And then on line 40, I have a displayPerson method, and that will output it to our console. And we'll look at the details of that in a little bit. But for now, let's run this and see what happens. So we can see the IDs at the top of the screen coming through. And then each of our records is clicking in one at a time, approximately a second apart. And the reason for that is the service actually has an artificial delay. I put that artificial delay in because otherwise things would run way too quickly for us to be able to tell whether things were running concurrently or not. So there's a little bit of an artificial delay in there. And since we have 9 records, down at the bottom, we can see our total time says 9 point something seconds. So it takes approximately 9 seconds just to run things one at a time. But of course, we don't want to do that because that's a waste of my time. So instead of running things synchronously, let's look at another option, which is using task to run these things asynchronously by using a continuation. And so this code is filled in. One of the topics I love to talk about is task and await and asynchronous programming in the C# world. So I'm kind of moving forward with the assumption that you have a general idea of how task and continuations work. If you want some more details of that, again, go to my website, follow the links for this talk, and I actually have a series of articles and videos that talk about task and await in C# if you want to brush up on that. So let's start on line 49. So for each, we're going to loop through our collection of IDs, just like we did with our synchronous process. And then on line 51, we call the getPersonAsync method again. And the difference here is this time we are not awaiting it. So rather than awaiting it and getting the person result that comes back, I'm grabbing the task itself. And so on line 51, we're assigning this to a task a person called current task. So what this means is that my for each loop is not going to wait for this 1 second method to complete. It's going to just continue and do this somewhere else, wherever the task scheduler decides it can run nicely. Now, once our initial task is complete, where we pull the data, we want to do something with it. And that's what we can do with a continuation. And that's what we set up on line 53. So we have our continue with method, and this takes our original task, the lambda expression that we have in here. The parameter is a task a person. And so on line 55, I can look inside that task and grab the result. And the result is the person object that we're expecting. And then on line 56, we can display that person. So this will basically run this for each loop and as quickly as possible. So it'll just kind of spin and go and kick off all these things. I'll say at the same time, but at the same time in the computer world. And so the rest of this code, if you look at, I have this all tasks variable that I have set up. So this is so that we can pause operation until all of our tasks are complete. So on line 47, I create a list of tasks. And then on line 59, I add the continuation task to that collection of tasks. And then the magical part happens on line 61. So I have a task.whenAll. So when I pass in this list of tasks to whenAll, it's going to pause operation until all of these tasks are complete. And so line 61, when I await this, is just going to sit here until all of our tasks are done. And so that way we know that this method won't exit until all of this is complete. So let's run this and see how it behaves differently. So again, I'll hit F5 to start this up. Okay, we've got kind of some good news and bad news here. The good news, if I look at the total time at the bottom, it says 1.45 seconds. So that's good. It did not take 9 seconds to run. That means I am actually running things concurrently. The bad is if you look at my output data, it doesn't look like this is displaying the way that I really want it to display. So let's take a look at what's going on here to try to understand that. And so we'll look at the display person method, which is down here at the bottom of our class. So I have a display person method, and this outputs 4 lines to the console with 4 console write lines. And the problem that we're running into is that our continuations that we have above, let's see if I can kind of get both of them on the screen at the same time. So our continuation of on line 56, where we're calling display person, these are going to just be called whenever the initial task completes. So if the initial tasks are kind of running all at the same time, the continuations are going to kind of run all at the same time. And so what we have is we have 4 console.write lines in the method, and we have 2 people entering this method at the same time. So these write lines are getting interleaved. So I have a couple choices. I could try to make this display person thread safe or thread aware, but I don't want to do that because, as we'll see with channels, it's unnecessary. So what I'll do is I'll grit my teeth a little bit, and in the continuation, I'll add a lock around the display person. So when we add a lock around this call to display person, this will only allow one thing to enter it at a time. So the next caller to display person will not be allowed in until the first call is complete. So we won't have to worry about this interleaving anymore. Now, when you lock on something, you do lock on a variable of some kind. And one of the nice things about this is it doesn't matter what you lock on. So I'm just using the all tasks variable because it's something that's handy in this method. So if I make that one change to lock around our output, then we'll see things are a bit better. So now we have our data that's coming out. Down at the bottom, our total time, we see it's 1.4 something seconds. And we did get all 9 of our records out. And since we are doing things concurrently, they're not in a deterministic order. So if we look at the ID property, the first thing we see we have a 4, then a 5, then a 3, then an 8, then a 9. So once you start doing things concurrently, things become a luck of the draw, I guess is the best way to put it. So this is a way that I've done coding for a really long time. And this was really kind of that first slide where, on line 51, we get something. And then on line 58, we do something with it. So it's really kind of creating that encapsulated, get the data, use the data, and then we're just doing a whole bunch of these. And that's how our concurrency is working. The locking, I always grit my teeth when I have to lock because I know there's overhead involved in that. And it turns out, in this case, we can use channels to use a different pattern that kind of works a little better in this scenario. Now, channels don't work great in every scenario because that would be the magical thing that happens well everywhere. But it does work well in this case where we have multiple producers, and we really want to consume the data one thing at a time because we want that display person method to just run one at a time without them getting interleaved. Okay, I'm going to pause for a drink of water because I've been talking really fast. Okay, so now on to the fun of channels. Now, the fun part about this is option 3 is not filled in at this point. I just have a placeholder here so the code will compile. So we get to start by writing some code. Now, the general way that I want to set up this producer-consumer workflow is I'll start by creating a channel. So we'll create a channel. Then I will start my consumer. Now, I often will start my consumer before I start producing, just so it's there waiting and ready to go. And then I will start my producer, and then I will wait for the producer to finish, and then I will wait for the consumer to finish. Okay, so let's go through this. First is creating a channel. Now there is a channel class that has some static factory methods that we can use. So you can see we have a create bounded and a create unbounded. And this basically decides whether we're going to have a maximum capacity on our channel or not. So I'm going to say yes in this case. We probably won't have time to play with this evening, but there's some interesting ideas with a bounded channel. Now, this is strongly typed, so we do need to give it the type of object we will put into this channel. So I'll say we have a channel of person objects, and there's nothing else that we can put into this, only person objects. And then we do need a capacity. I'll set the capacity to 10. And this is actually a cheat because I only have 9 objects. So we're never going to reach capacity. And quite honestly, this particular example would be hard to demonstrate when we are hitting capacity. So what happens is when we have writers to the channel, there's a couple different ways to write. One of them is to say, okay, I'm going to write async. And that's actually what we'll be using a little bit later. If the channel is full, meaning it's at capacity, then that write async is actually going to pause until there's space available inside the channel. So as soon as somebody reads off the other end, okay, there's space, now I can write. If I do, I'll say not asynchronous operation, there's also something called try write, where I can try to write to the channel. That will just fail. It will return false and say, I couldn't write to the channel because it was full. So the capacity can have a throttling effect. So if you start thinking about, oh, how can I use this? You might say, okay, well, this is how many items I can process at one time. So again, won't be talking too much more about that this evening. Now, I want to start by creating the producer, and then we'll come back to the consumer. So my producer, in fact, we'll create this as a task. And we'll say produce data. We'll pass in our list of IDs and part of our channel. Now, as I mentioned, channel has a separate reader and a separate writer property. And this is one of the things that I like about it, because if I pass in a writer, what I'm doing is I'm explicitly stating I am only going to be writing to this channel. If I pass in a reader, I'm saying I'm only going to be reading from this channel. And what that means is the really smart people that build the compiler and runtime can do optimizations. And that's stuff that me as a programmer who's just trying to get stuff done for my users doesn't really care much about. Okay, now this method doesn't exist, so I'm going to have Visual Studio create this for me. I'm going to hit Control Dot and generate that method. And that just created the signature that I wanted, which is a method called produce data, returns a task, takes a list of integers as a parameter, as well as a channel writer as a parameter. Now, if you look at the parameter for the channel writer, you see there's a separate type, which is channel writer of T. And so that's the actual type of the writer property. Okay. So let's start by kind of doing the same thing that we did in our other methods, which is for eaching over the IDs. And then I will want to call that getPersonAsync method. So I'm going to, let's see, called what? People reader, person reader. It's always good if I remember the names of my objects. So, and this wants me to put async up here to make the await happy. Yes, okay. I don't like red squigglies. So I'll await the getPersonAsync method so that I can get the person object. And then the channel writer, okay, so that we can see the full signature. It has a write async method where I can put that person onto the channel. And since this is an async method, we should await this as well. But I have a problem with this because if I await getting the person and then I await writing to the channel, line 87 is going to cause this. It's actually the same line that I had in my option 1 synchronous process on line 39. So it will take 9 seconds to complete. Okay, well, I'm going to use some magic of task and asynchronously, or asynchronicity, and extract these 2 lines to another method. So I'm going to extract these, and we'll call this fetch record. So now I have a separate method on line 91 called fetch record that returns a task, and it's the one that's doing the awaiting of the get person async and awaiting of the writing async. Now in my produce data method on line 87, I'm not going to await this. Instead, I'm just going to let it go. I'm not going to await this task, which means this is going to produce a task. And that means this for each that I have on line 85 is just going to spin. It's going to spin as fast as when I was doing the tasks manually. Now, again, I've got a green squiggly here because it's saying, well, you're not awaiting this. And so I'm just going to have this annoying green squiggly on here. One thing you can do to get rid of that is to use a discard for the task. So right here, I'm telling the compiler, you know that task that's coming back from this fetch record? I'm going to ignore it for now. So don't worry about it. Now, I do need one other thing, actually a couple other things. Since I'm not awaiting anything, I can remove the async keyword, but I do need to return a task from this. And this code isn't going to do what we expect it to do. So this will change in just a bit. But rather than changing the return type for this method, I'm going to return a completed task. So what's going to happen is this for each is going to spin through these 9 items, call the fetch record on line 92 9 times in this case, and then it's going to return a completed task. Again, this code's not going to do exactly what we expect for now, but we'll pretend that it does so that we can fix it later. Okay, so after I start my producer, I want to wait for it to finish and say, so I can say await producer, and that will make that part happy. Now, the last piece I need is my consumer. I need something that's reading from the channel and doing something with the data. So I'll kind of do what I did with the producer. I'll let Visual Studio, if I can spell consumer. That sounds good. And we will call this show data. And this will take a channel, it will take our channel.reader property as a parameter. And so what we'll be doing is we'll say, okay, well, this is going to read from the channel and then do something with the data. And like I did before, I'll put my cursor there and hit Control dot, say, hey, generate this method for me that doesn't exist yet. And now we have it down on line 85. So again, we have our show data method that takes a channel reader of person as a parameter. And this reader has a lot of things in it. There's, I would show you some of the other ways of doing it, but I'd rather just show you the cool way and get it done with. If you want to see the other ways, in the links for this talk, again, I've got some articles that I've written that show other ways of reading data. I'm going to use the read all async method because I find this the most interesting because this combines 2 of my favorite things. Read all async, if I hover over this, it returns an async enumerable of person. So what are my 2 favorite things? Well, one of them is enumerable and enumerables in general because I can for each over them. And for each is one of my favorite things in C#. I love for each. The second thing, which I won't say it's one of my favorite things, but it's something that I have to deal with all the time, is async code. So so this combines async with a for each potentially. So let's see how we use this. So I could say for each person in read all async, but I'm going to get some red squigglies here once the compiler catches up, because it's going to say, oh, well, no, this doesn't return a person. What are you doing? Well, the magic thing to do is put an await before the for each. And what I've just done is created a for each loop that is going to wait potentially at each iteration for a new item to be available. So if there isn't a new item there yet, then this is going to pause operation, and again, in a nice concurrently friendly way, until there's an item available. And then it'll give me that item and I can go through it. So again, kind of the best of for each, which is amazing, and awaiting tasks. And then in here, we can say display person and then pass in our person object. Now, we don't have to worry about locking in this case because this is a for each, and a for each runs things one thing at a time. So if I have 8 things in the channel, it's going to read the first one, call the method, read the second one, call the method, read the third one. It's, you know, an enumerable is a next, 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 next. Give me the next item. And this is the only code we need to read everything off of the channel. So our last step is to wait for the consumer to finish. So we'll await the consumer here at the bottom. And this actually sets up our basic consumer-producer or producer-consumer relationship. So let's see what happens. I'm hopeful, but not real hopeful because I've done this wrong a lot of times. So let's run this and see what happens. Okay, so initially, it kind of looks okay. So at the top, I have my 1 through 9 values. And then if I scroll, I see I actually have all 9 records. But I have something missing at the very bottom. I have the total time is not showing up. And that's because this hasn't finished yet. It's still going. And what's happening is that my for each on my listener is waiting for the next record to be put onto the channel. Now there's a piece that we need here, and we need to somehow tell our listener, our consumer, hey, there isn't going to be any more data. And that's where the idea of marking the writer as complete comes in. Now, I have a problem when I'm talking about C# channels because I usually talk about closing the channel, and that's actually terminology from the Go world, which is where I was introduced to channels. So technically, we don't close the channel. Technically, we mark the writer as complete. So where I would think about doing that is after my producer is done. So I could say channel.writer.complete, and that's actually a method. And say, okay, well, once the producer's done, we'll mark the writer as complete. And then for the consumer, it's going to, the read all async is going to drain any remaining items in the channel. And then if there's a channel that is empty and the writer is marked as complete, then this for each will exit. Okay, that sounds pretty good. So let's do that. Oh, this is not at all what I expected. So yes, my thing didn't run and it completed almost immediately. Yeah, that's a problem. And anyone who's done parallel programming or any type of manual task operations, I guess I'll say, has experienced things like this, and it's a little bit frustrating. So what's happening is our produce data function that we have on line 95, again, that for each just spins real fast and it finishes real fast because we're not waiting for things to be done. And then we're returning a completed task. And what that means is up in our kind of main producer consumer flow, on line 77, we create this producer, we kick it off, and then we await it on line 80, but as soon as we await it, it's done. It's going to be complete before it even has time to work on the separate threads. So yeah, this isn't going to work. And what I'm going to do, this is one solution. There's all kinds of different approaches, which is interesting in this world, a lot of different patterns. I'm going to use the when all that we saw with a previous example. So we'll create a variable to hold all of our tasks, and we'll create a new list of tasks for this. And then in our fetch record, I'll say all tasks dot add. So instead of discarding the task that is returned from fetch data, I'll add it to my task list. And then we won't return a completed task. We will await task.whenAll and await all of these tasks to complete. And I'll need to add an async back into my method since we're awaiting something now. And then after this is done, I'll mark the writer as complete. So I'll do this actually in the produce data method. Since I only have a single produce data method, seems like a good place to put this. And so now what will happen is our processes, or I'll say our fetch records will still all kick off kind of concurrently. Well, concurrently as close together as possible. But then by awaiting all of these tasks to finish, we know that line 103, closing the, completing, marking the writer as complete, try to get my terminology right, will not happen until after all this stuff is done. So now, fingers crossed, we run it again, and now we get the output that we expect. So up at the top, we have our list of IDs. We have all of our data coming through. And then down at the bottom, we have our total time, okay, 1.4 something seconds. So I think this is like kind of compelling. And I know this example is fairly trivial, but I want to show you where I've used this in the real world for certain definitions of real world. But before that, let's just kind of review. And I'm going to take out these comments since we have filled all of this in, so that we can kind of see the basic idea. So again, the first part on line 70 is I create a channel. Then on line 72, I start my consumer. So I kick that off first. On line 73, I kick off my producer. On line 75, I wait for the producer to finish. And on line 76, I wait for the consumer to finish. And so I've used this pattern kind of over and over again. And one thing I like, even though it is more code than if we have the task with the continuation, in fact, I ended up with 4 methods instead of 1. I like that I have this kind of very clear flow in this run with channel method. You know, it's like, okay, create the channel, start the consumer, start the producer, wait for the producer, wait for the consumer. And to me, this is very visually, well, I'm used to this. So to me, it's visually obvious what's going on. Of course, your mileage may vary. Okay, so I'm going to show you the real world one, and then we'll come back and pick up any questions that people might have had, because the real world option will probably help answer some of those questions, like why would I want to do this? So the other project, the code file that I have in the repository, is a hobby program that I have, which I call it discount machine learning. And this does some handwritten digit recognition. Let me run this to start with. I'm not going to get into all of the details of the code. And the repository has this simplified version of the project and also links to the real repository. So if you're curious, you want to explore it more, there's some console applications and some various options on the way I do things and a bunch of articles about it. So those are all linked from the repo. So I'm going to hit go here. And really the idea behind this application is I was doing some kind of machine learning exercises, and I was a little frustrated because it was using this data set, which represented handwritten digits, which we can see are clicking in very slowly right now. And what I didn't like about it is it said, okay, well, if you use this algorithm, it's 92% accurate. Once we get to the bottom, we get a little percentage. And then if we run this algorithm, it's 94% accurate. And that was the total results. And I'm like, you know what I would prefer? I would like to see which ones the algorithms are getting wrong and maybe compare the two. Because if one of them is the more accurate one getting the same one wrong, but fewer of them? Or is it getting different ones wrong? Is it getting the same ones wrong in a different way? So I built this visualizer. And this shows me, for example, here's one that this particular algorithm, there's the image, which to me looks like an 8 as a human. It said, I think this is a 5. The actual value from the data set is an 8. And then here's one next to it. Okay, again, to me, this is a 9. But this algorithm, based on what's there, says, oh, I think this is a 7. Now, this that I just did, that took 44 seconds to run, that has no parallel code in it at all. And so each item takes approximately a quarter of a second to complete. Now, as someone who was working with this and running it a lot, because I wanted to tweak things and see different results and tweak things and see different results, this is not appropriate because it's like, I'm not using my machine to the fullest. And this is a CPU bound operation. So it actually takes CPU cycles. So I said, okay, I should do this in parallel. And I actually started out doing parallel code using the task with the continuation. But then I also created a version that uses the uses channels. Okay, yes, and here it is. So there's a start method inside this user control, and this code looks blindingly familiar based on what we just saw. So in this case, I have a user control in a WPF desktop application. And the start is when I say, hey, okay, go, kick yourself off, start processing. Line 102, we create a channel. And in this case, it's an unbounded channel. I said, okay, well, let's just let the computer do as many as it can. That's basically what I said. And then again, start the consumer. In this case, I call it a listener. Okay, so let's listen on the channel and let's produce to the channel writer. And then we'll wait for the producer to finish, wait for the listener to finish. And before looking at the details of those, I'll just run it so you can see what the differences are. And this is amazing because I recently got a new machine that has twice as many virtual cores as my last machine. So now these 375 records run in 5 seconds. And on this particular machine, I have 16 virtual cores. I believe I have it throttled back a little bit so that I would hopefully not interrupt my streaming. But it seems to be coming across on Twitch okay, so we'll go with that. But this runs about twice as fast as it did on my old machine. And if we compare it to the single threaded version, I'll call it, it runs like 9 times faster. And to me, that is very compelling. If I'm not going to wait for that to finish. If we look at what our producers and listeners look like, again, this will look very familiar. So let's go to definition here. So on our listener, I'm doing the read all async with the await for each on it. And then in the middle, create the UI elements. And this actually turns a string of digits into a bitmap so it can display the bitmap. There's a text box with the predicted value in it. And then that's all wrapped in a control that can then be put into a WPF list box. So that's what that part is doing. The produce, which is right below this, a little more complicated than what we saw in our other example. The line I want to look at is line 89. So I have a predict function. And this is my long-running process. This is my heavy CPU cycle process. So this is the method that I really want to run in parallel so that I can produce the data, multiple datas at the same time. Multiple datas. So I can use all of my CPU resources is what I should say. And this has a little more processing. Now, one difference here is you'll notice on line 83, I'm not using a for each, I'm using a parallel for each. And one of the main differences for that is line 89, the predict function is not asynchronous. So that is not an asynchronous method. And so using a parallel for each is, I'll say, a pretty quick way of getting, non-asynchronous methods to run concurrently. Just as a warning, if you've ever used parallel for each, don't await anything in it because that just creates chaos. So if I do a parallel for each and I have no awaits inside of it, then so we'll say this is line 83. So the next line, outside of the loop, which is, kind of confusing, it won't run until all of the iterations of the parallel for each have completed. So that's one nice thing. As soon as you await something, then you kind of have the problem where it completes immediately rather than waiting for all of them to complete. So one piece of code that I have in here that I do not like but works is on line 91, I write to the channel and I call the write async method in this case, but I'm not awaiting it. This makes me uncomfortable, but it works. I will say that this code is still in flux, so I'm going to be working on this some more. Now, one other thing that you'll notice is on line 81, I'm taking this entire parallel for each and wrapping it in a task. The reason I'm doing that is because I'm running in a WPF application, which is a desktop application with a UI thread, and running this whole thing in a task gets it off of the UI thread so that it'll run nicely. If I did not run this in a task, again, this parallel for each would block, and it would actually block my UI thread. So my application would lock up. So this just kind of says, okay, run all of this, but not on the UI thread. And then on line 95 down at the bottom, once this is all done, we mark the writer as complete. So it's kind of a really interesting idea of, okay, let's use this producer-consumer relationship, to kind of create something that's not too hard to look at. So yeah. So I'm going to flip back to the slides and see how I did on the topics that I promised to talk about. Okay, well, we did talk about creating a channel, and again, create bounded will create a channel of a particular size, so it has a limited capacity. If channel writers are full, writers are blocked. So if you do a write async, it's going to pause. If you do a try write, it will fail, or return false, I should say, which I guess is a failure. And then the channel has a separate reader and writer property. The reader is a channel reader of T, and we saw how to use read all async, which is that cool async enumerable that you can await for each over. And then the writer property is a channel writer of T, and we used the write async to write something onto the channel, as well as the complete method to mark the channel as complete. There'll be no new data, which is what we said here. We just wrote to the channel and then we marked it as complete. And again, marking it as complete indicates no further data will be written. If you do try to write to a completed writer, it will throw an exception. Often it throws an exception on another thread that you don't see, but it will. And if you're reading from a completed channel, it will continue to read normally until all of the data is drained. But as soon as the channel is empty, then it will stop reading, which is actually what we show here. So when we are reading with the read all async, as soon as it's complete and there's no data, the for each loop exits and life goes on as normal. Now, there are some other things if you want to dive into it. The channel reader has a wait to read async. So that's a method that you can await, and it will return a true as soon as there's an item available on the channel that you can read. And it will return false if the channel is closed and empty. Otherwise, it will wait with the await. There's also a read async to read a single item, and a try read, which is a non-asynchronous read operation, and that will return true or false, whether it's successful or not. On the channel writer side, I kind of talked about there is a wait to write async, and this will say if the channel's full, tell me when there's capacity available. A try write, which again, if there's no capacity, the write may fail. There's also a try complete, and I'm not exactly sure why there's a try complete, because it seems to me that complete should just work. Potentially, actually, now that I'm thinking about it, it could be that try complete might fail if it's already marked as complete, but I would need to look into that. And then there's a little bit of other stuff. We saw there's a create unbounded channel as well. And then if you're really into optimization, there's channel creation options. And this is an optional parameter you can pass to the create bounded or create unbounded. So you can indicate there's only going to be a single reader or a single writer. And in that case, now the compiler and or runtime can do optimizations and say, hey, all that stuff where we have to worry about, concurrent entry into this, well, we don't have to worry about it because this is marked as a single reader. So we can optimize for that. And then there's also a third one called allow synchronous continuations. And honestly, I don't understand what that does at all. If you look at the documentation, there's a paragraph that talks about it, and it looks like an edge case. But it looks like something where if you are trying to optimize for performance, that it could be useful. The good news is it also sounds like the default values work for most people. So unless you're actually having performance concerns, you don't really need to worry about those. And so that's actually what I have for you this evening. Again, I've seen the link go through Twitch a couple times. But here is the GitHub repo that has the slides and the code samples in them.